I'm Nick Chikolsky.
I'm Nathan Wynn,
Noah Springer.
I'm Charles McCann.
and this is going to be our Lab 4 discussion. So, um, first one is discuss with your team the technical or conceptual issues you had performing the experiment and how you overcame them.
Well, for me, I was just kind of like struggling to make sure it doesn't like spin around as I'm letting go of it. So I kind of just like took a couple test runs to make sure I got the pattern down right.
Yeah,
I'd
if
say
it okay, go ahead.
you can go. Oh, okay, I'll go. I was gonna say new one. If you're gonna talk on that, you can continue.
Yeah, I was just gonna say like it messes up the direction if it spins around too much. So it's important to keep it upright so that it can measure the direction it's traveling in properly and the forces the according forces on the spring.
Another issue I had was with materials. I didn't have any strings, so I just used something else that I had. Like I used a chain, but where I was swinging it, it would move more than I wanted it to. So to get around this, I just had to like tie it around and make sure it was secure so that it would actually track it right.
Right. And that's because the chain doesn't have um as much like spring force as I would assume within it. Like it probably doesn't stretch as much because it's harder. So it just goes back and forth without like you get, I guess you can say it wouldn't really bottom out because it doesn't have to like escape that position because it's just staying the same length the entire time. Whereas like if you use like a spring or a string and
It might change
the
a little
string
bit. Yeah,
stretches a little bit. I mean, it's negligible, but like if we're
right.
talking about the forces that it acts on, I mean, if you scale this up into something much bigger, then it will start to make a difference. Um, so yeah, I think
Um,
that's just something to consider.
yeah, for me, I also like had like a similar problem to Noah, or like I didn't really have a string to hang it off of, so I just grabbed a lanyard and I hooked the the hook part onto the lab kit. And then like another thing was I didn't really I also didn't really have a place to hang it off of. So like I kind of hung it off like the lamp that I had. But like the problem was that the lamp wasn't exactly sturdy, so it would swing when um the pendulum also swung. So I had to hold it still. So yeah, that's pretty much it. So next one is share your findings due to your experiments with the members of your team and compare their observations with yours.
Anybody want to go first?
Mm,
I think it's basically just comparing what we had for our graphs. I think they all look similar, but you can tell that there was definitely error in some experiments compared to others.
Yeah, I definitely noticed like with my graphs, I wasn't getting like the perfect like parabolas that it
Mhm.
showed in the graph.
Yeah, same with mine for sure.
Right. I think that's less of like what they're trying to
Right.
get at because I feel like there's always going to be an error. I feel like they're more kind of showing like what are the trends in like the maximum, minimum acceleration and like what does the mass how does the mass affect it and how does the length of the pendulum affect it? And I figured that if the pendulum is longer, and we know that the force of acceleration on any object here on Earth is the same, the gravitational acceleration. So just if the pendulum string is longer, it's going to be that I guess the time it's going to be taking on each side of the pendulum is going to be longer. It's going to be traveling, down more and less, across. But once it finally bottoms out, because it's been traveling, down with the force of gravity on it, acting on it for so much longer, it's going to have a higher acceleration once it bottoms out. And the same thing for when it travels back the other side. The force of gravity is going to be much stronger on the other side. Or no, the force of gravity won't be stronger per se, but it'll definitely, because it's traveling longer up the side, it'll be acting on it for longer. over a longer period of time, because just because the string is longer, you know, it has a longer, you know, side to the pendulum. So I think that's what they're trying to get at.
Yeah, I think although we did all have like different lengths and different, you can see the accelerations and forces are different, but all the graphs very much look similar even for these differences too. I
Right,
think that's
right,
a big
right.
thing too.
Nice.
You guys have anything to add?
Not really. It's just I think you guys covered like basically what I was gonna say.
Okay.
Cool, cool.
Yeah.
I think there's
Um,
just one more.
what was
Oh,
it?
Q12.
13.
Yeah, it was
Yeah,
13. You
it's
just
13.
passed
Oh,
it.
this one. This one. This one.
Discuss
Okay.
with your team the answers to Q12. Okay.
I said that I found more difference in the motion for the longer length because there was just like more time to show more change
Hmm.
in addition
Yeah,
to the longer time step to show more change.
Right. I think we all agreed on this one. That there would be a greater discrepancy in the longer one, and that's just because it has a longer trajectory. You know, it travels from side to side to side. It takes more time to travel from side to side, basically. And then with you know, a time interval that isn't super precise, I feel like it would just less accurately show the motion of the pendulum, especially if we're doing this for our experimental and less for the theoretical, like the glow script. I feel like if we use a time interval like this, or like, yeah, if we use the time interval that wasn't super specific and we weren't getting those nice curves, it would really show a discrepancy in our data and it would look really weird. So I think it's good that we use a pretty precise time interval.
Yeah, I think it kind of aligns with like what you said for the previous question, where like um a longer length results in like, or when you look at the graph for a longer length, there's like bigger amplitudes and like the periods are a bit longer, and that's like a result of the acceleration of gravity just acting on the mass for a longer period of time.
right. And since we're changing the time interval to be like a shorter time interval, it makes sense that the longer one would show more, just because the longer one has a longer time interval to get more data for the smaller points.
Right.
So since it's longer, you just get, you can tell that it's a bigger difference, because the shorter one, it's not much of a difference since there's just not as much data.
Nice.